In this video, we're going to look at how to solve trigonometric equations using the auxiliary angle method. For our example, we're going to look at how to convert this expression, root 3 sine theta minus cos theta, into the format of r sine theta minus alpha, where r is greater than 0. And after we do the conversion, we're going to use the result to solve the equation root 3 sine theta minus cos theta is equal to 1 for theta between 0 and 2 pi. For the first part of this question, we're going to need to express root 3 sine theta minus cos theta as r sine theta minus alpha with r greater than 0. Since we've got sine theta minus alpha here, we're going to make use of the identity sine A minus B is equal to sine A cos B minus sine B cos A, so that we can rewrite sine theta minus alpha as sine theta cos alpha minus sine alpha cos theta. Next, we're going to multiply the r to every single term inside the bracket, so that our right-hand side becomes r sine theta cos alpha minus r sine alpha cos theta. The next step now is to equate the coefficients of sine theta and cos theta on the left and the right hand side. Since this is an identity, the left and the right hand side are always going to be the same for all values of theta. So if we look at the sine theta term on the left and the sine theta term on the right, root 3 must be the same as r cos alpha, since that's the coefficient of sine theta. So we've got r cos alpha is equal to root 3. If we now look at the coefficient of cos theta on the left and on the right, on the left-hand side, the coefficient of cos theta is -1, and on the right, we have got negative r times sine alpha as the coefficient of cos theta. So by equating this, we're going to get r sine alpha is equal to 1. Now that we've got these two equations, we can use it to solve for r and alpha. First, we're going to call these equations 1a and 2a. I'm then going to square equation 1a so that on the left-hand side, the square of r cos alpha becomes r squared cos squared alpha, and the square of root 3 becomes 3. Doing the same thing to equation 2a, the square of r sine alpha becomes r squared sine squared alpha, and the square of 1 is just 1. And similarly, I'm going to call these equations 1b and 2b. Then to solve for r, I'm going to use equations 1b and 2b. We're going to add them together. So the left-hand side is the addition of r squared cos squared alpha plus r squared sine squared alpha, and the right-hand side is addition of 3 and 1. We can factorize our r squared from the left-hand side and rewrite it as r squared times sine squared alpha plus cos squared alpha is equal to 4. Now remember, we can use the trig identity sine squared theta plus cos squared theta is equal to 1. So we can replace this sine squared alpha plus cos squared alpha here with 1, so that r squared times 1 is just r squared, and the left-hand side simplifies to r squared, and the right-hand side is 4. Now from the question, we were given that r is greater than 0. So this means that we're going to take the positive square root of r. So we have got r is equal to 2 as our answer. Next, we're going to solve for alpha. And to do that, I'm going to make use of equations 1a and 2a. To solve for alpha, we're going to say equation 2a divided by equation 1a. So we're going to get r sine alpha over r cos alpha is equal to 1 on root 3. The r will cancel out, and we're going to make use of the identity sine theta on cos theta is equal to tan theta, and we're going to rewrite sine alpha over cos alpha as tan alpha is equal to 1 on root 3. Now if we think about the values of cos alpha and sine alpha, both are positive. So this means that since sine alpha is positive and cos alpha is positive, alpha has got to be in the first quadrant between 0 and pi on 2. So using the exact value for tan alpha is equal to 1 on root 3, we can conclude that alpha has got to be in the first quadrant and is equal to pi on 6. So all we need to do in order to answer the first part of the question, where we're asked to express root 3 sine theta minus cos theta in the form of r sine theta minus alpha, all we need to do is substitute the values we've just found, r is equal to 2 and alpha is equal to pi on 6, into this expression, so that we have got root 3 sine theta minus cos theta is equal to 2 sine theta minus pi on 6. And what that means is that if you were to plot the graphs of both of these functions, they're essentially the same function. And in this diagram obtained from Desmos, they're essentially on top of each other. We can now use the first part to help us solve the equation in the second part. We want to solve root 3 sine theta minus cos theta is equal to 1 for theta between 0 and 2 pi. So we're going to replace the left-hand side of this equation with 2 sine theta minus pi on 6 is equal to 1. And this equation is much simpler to solve because it has only one trig function sine instead of two trig functions sine and cos. To begin, we divide both the left and the right-hand sides by 2. This is going to give us the equation sine theta minus pi on 6 is equal to a half. I'm then going to define u to be equal to theta minus pi on 6 so that we're solving the equation sine u is equal to 1/2. But if you look at the domain for theta, theta goes between 0 and 2 pi. So I'm going to subtract pi on 6 from every term. And because u is defined to be equal to theta minus pi on 6, we can replace this with u so that the domain of u is between negative pi on 6 and 11 pi on 6. So if we think about sine u is equal to a half, because this is positive, we can conclude that u has got to be in quadrant 1 or quadrant 2. If u is in quadrant 1, then u is going to be equal to pi on 6. But because we define u to be equal to theta minus pi on 6, we've got theta minus pi on 6 is equal to pi on 6. Therefore, theta is equal to pi on 3. If u is in the second quadrant, we're going to have u is equal to pi minus pi on 6, which is 5 pi on 6. So we've got theta minus pi on 6 is equal to 5 pi on 6, and adding pi on 6 to both sides, we have the other solution for theta, which is theta is equal to pi. So the solution to our equation root 3 sine theta minus cos theta is equal to 1 are theta is equal to pi on 3 or theta is equal to pi. And what that essentially corresponds to, it is the points of intersection between the horizontal line y is equal to 1 and the graph y is equal to root 3 sine theta minus cos theta. So you can see here that they intersect when theta is equal to pi on 3 and when theta is equal to pi. Thank you everyone for watching the video. I hope you guys found that useful. For more videos on this topic or other topics, please check out our channel. We do try to release videos regularly, so if you haven't already, don't forget to subscribe, and we hope to see you all in our next video. Bye for now.